Now in case B, the pulleys are moving, and in the case of moving pulleys, the acceleration of the blocks on the either side of the moving pulley is different. What I mean to say is the fact that if in this system there is a pulley, this pulley is at rest, and it is due to the fact that its center is being connected by a rope which is connected with a rigid roof from the other end. So this pulley is at rest, this is at rest, and this is moving. So I have to identify the moving and the moving pulleys and the pulleys at rest. Now the tension in the rope, let's suppose it is T1 and it is also T1 because the rope is same, and the acceleration of this 2m mass is A1. Okay, now if the acceleration of 2m mass is A1 in the upward direction, then the acceleration of this pulley will be A1 in the downward direction. And this is also due to the fact that the pulley situated between 2m and this pulley is at rest. So if this pulley is at rest, the acceleration on its either sides, at this side and at this side, will be equal. So this pulley will also move with an acceleration A1 downwards. Now let us assume that this M is moving upward with an acceleration A2 and this M is moving downward with an acceleration A3. Now why I have assumed these accelerations to be different is a fact which I have already told you, that the pulley which is between these two masses, this pulley is moving in downward direction, and if it is moving, then the acceleration on its either sides will be different. So let us assume the tension here as T2. This is T2 and this is also T2. Okay, now I'm writing the equation for 2m block. I'm writing the name as A, this is B, this is C, and this pulley is P. So for block, I'm starting from here, for block A. So A block is moving upward, so T1 minus 2mg is equal to 2ma1. As this block is moving upward, therefore T1 will be greater than its 2mg. So this is the equation number 1. Now for pulley P, I'm writing the equation that the force 2T2, this T2 and this T2 is acting downwards and pulley is moving downwards. So 2T2 minus T1 is acting upward and it is equal to MA. Now it is very important to note that we have already assumed that the pulleys are massless and hence MA will be 0. So I can say that that 2T2 will be equal to T1, and this conclusion will be used in the further problems directly. I'll be equating the tensions on the upper side and the downside of a pulley, moving pulley, if it is massless directly. So I can say that for a moving pulley, massless moving pulley, the tensions acting in upward direction and the tensions acting in downward directions are equal to each other. Okay, now this is the equation number 2. The third equation is for block B. For block B, it is moving in upward direction, so I can say that T2 minus mg will be equal to ma2. This is equation number 3. And for block C, the equation will be 2mg minus T2 will be equal to 2ma3. This is equation number 4. Now we have to count the number of variables and number of equations which we are getting. That the number of variables are T1, T2, A1, A2, A3, and the number of equations which we got is 4. So we need one more equation to solve all the variables, and that equation is very important one. That is constraint motion equation. Constrained motion equation. And in these case B problems, we'll be emphasizing more on these constrained motion equations, and we'll be practicing more and more with new problems. So the method 1 which I am demonstrating for the constrained motion equation is the relative acceleration method. So we already discussed that if the pulley between any two masses is at rest, then their acceleration is same. We have already discussed this fact. Now we are watching in this problem that this pulley P is moving, and therefore it's the acceleration of B and C are different. So if we find out the acceleration of B and C with respect to pulley P, so with respect to pulley P, I can draw the free body diagram. That if I'm in the frame of pulley P, so I can assume that pulley P is at rest. This is a very important concept of relative motion, that if you are an observer, then you are in the state of rest with respect to yourself. So if we are assuming that pulley P is observer and we are getting into the frame of pulley P, then its acceleration will be same. The acceleration of the blocks on the either side will be same, because we have assumed the pulley P to be at rest by making a proper calculations. So if the pulley P is at rest and we are in the frame of reference of pulley P, then the acceleration of 2m with respect to pulley P will be a3 minus a1. Relative acceleration of 2m with respect to pulley P will be a3 minus a1, and relative acceleration of m with respect to pulley P will be a2 plus a1. And you can see that 2m mass and pulley are moving in same direction, so I am writing a3 minus a1, and m mass and pulley is moving in opposite directions, so I am writing the relative acceleration as a2 plus a1. So now writing these accelerations in the frame of pulley P, I can equate these accelerations directly, that a3 minus a1 will be equal to a2 plus a1. So a3 minus a2 will be equal to 2a1. This is the required fifth equation which we need for solving out or for evaluating these 5 variables. So what I've done, I can summarize the constraint motion equation, that I know that due to the fact that pulley P is moving, the accelerations of block B and C are different. But if I am calculating the accelerations of B and C with respect to pulley P, then I can assume the pulley P to be at rest. And if we have assumed the pulley P at rest, then we can say that the acceleration of 2m and m with respect to pulley P will be same, must be same. So this is the method 1 of writing the constrained motion equation. Now we move on the next problem. Now in this question, I have to find out the velocity v of this block, and I can identify that this pulley is at rest and this pulley is in motion. So the acceleration of the velocity of this block and this block will be different. Now I'm using the method 1 of constrained motion to calculate the velocity v. And in method 1 I can say that if this block is moving with 4 meters per second and this pulley is at rest, this is at rest, so this pulley will be moving downwards with 4 meters per second. Now with respect to, this is pulley P, with respect to pulley P, I can redraw the free body diagram. I can redraw the pulley diagram, and pulleys are also known as Atwood machines. This is pulley P, and the velocity of this block, which is on the left side of the pulley P, will be 6 plus 4, which is 10, and the velocity of this block, which is on the right side, will be v minus 4. This requires a little bit of knowledge of relative motion, and this is very easy, that when the two blocks are moving in opposite direction, then we add up their velocities to calculate their relative velocity, and when they are moving in opposite direction, in same direction, then we subtract their velocities to find out the relative velocity. And one more important thing, that we are calculating the relative velocity of this block with respect to pulley. So we are writing the equation as v minus 4. Okay, if we are calculating the velocity of block with respect to pulley, then relative velocity will be velocity of block minus velocity of pulley. But if we are calculating the relative velocity of pulley with respect to block, then the equation will be velocity of pulley minus velocity of block. Okay, so now I can equate these two, that v minus 4 will be equal to 10, so v will be equal to 14 meters per second. This is the required answer. And we are not concerned about the writing equations of tensions and mg, because that is very easier part, and it is the same in all the questions. So I am skipping that part, which I have already told or already discussed in previous question. Now moving on, next method. Now in this question I need to find out the velocity of this block v, and I'm using again the method 1. So I can see that there are two moving pulleys, this one and this one, and let us assume the velocity of this pulley to be upward Vp, and velocity of this pulley to be downward Vp. And the velocity of these two pulleys will be same, due to the fact that the pulley between these two, this one, is at rest. So with respect to pulley 1, this is pulley 1 and this is pulley 2, I can say that 2 minus Vp is velocity of this block with respect to pulley 1, and velocity of this block with respect to pulley 1 will be equal to 3 plus Vp. Okay, so Vp will be equal to minus 1. Vp will be equal to minus 1. Now in fact 2 Vp will be equal to minus 1, and Vp will be equal to minus half. It means that I've assumed that this pulley 1 is moving upward, but it is moving in downward direction. Now for pulley 2. For pulley 2, I can say that velocity of this block, this one with respect to pulley, is 4 minus Vp, and velocity of this block with respect to pulley is V plus Vp. Now Vp is minus half, so V will be equal to 4 minus 2 Vp. So V will be equal to 4 minus 2 into minus 1 by 2, which is V is equal to 5 meters per second. This is the required answer. Now I move on next question.